Welcome all. So, myself Tilagavadi. I am working as an assistant professor in Department of Information Technology at Kumarasamy College of Engineering. So today we will discuss about spanning tree in data structures concept. So let us move to on the topic. So in this article we will discuss the spanning tree and the minimum spanning tree. So before that we are going to discuss two words about the graph. So what is graph? Graph can be defined as a group of vertices and edges to connect these vertices. So what are the types of graphs? So already you have know about the types of graphs. So there are three types. One is undirected graph, second one is connected graph, third one is directed graph. So in this article we will discuss two words about the spanning tree. So what is spanning tree? A spanning tree can be defined as the subgraph of undirected connected graph. That is a subset of graph that does not have cycles and it also cannot be disconnected. So that is called spanning tree. So in the how many edges and vertices are to be in spanning tree? So spanning tree consists of n minus 1 edges, where n is the number of vertices, or it called as nodes. Edges of a spanning tree may or may not have weights assigned to them. So a complete indirect graph can have n power n minus 2 number of spanning trees, where n is the number of vertices in the graph. So for suppose we can take an example. If node n is 4, the n is 5, the number of maximum possible spanning tree would be 5 power 5 minus 2. So totally how many spanning tree would be framed? 125 spanning tree would be framed. So next, what are the properties of spanning tree? Let us see some properties of spanning tree. So there can be more than one spanning tree of a connected graph G. So only one spanning tree that should be connected a graph G. Spanning tree does not have cycles or loops. If you are forming a cycle or loop, that cannot be a spanning tree. That cannot be called as a spanning tree. Spanning tree is minimally connected. So removing one edge from the tree will make the graph disconnected. Spanning tree maximally acyclic. So adding one edge to the tree will create a loop. So we have discussed about the spanning tree consists a maximum of n power n minus 2 number of spanning trees that can be created from a complete graph. Spanning tree has n minus 1 edges, where n is the number of nodes. If a graph is complete graph, then spanning tree can be constructed by removing maximum of e minus n plus 1 edges, where here e is the number of edges and n is the number of vertices. So let us see the example. So consider we are having a graph A, B, C. From that graph, how we are constructing a spanning tree in the sense. So the constraint is we don't have any cyclic formation. So we have to remove one edges, that is n minus 1 edges. It consists of total number of edges 3. So it consists of 2 edges. So this is an example of spanning tree. So next we are going to see about minimum spanning tree. Minimum spanning tree can be defined as the spanning tree in which the sum of weights of the edge is minimum. The weight of the spanning tree is sum of the wedges given sum of weights given to the edges of the spanning tree. So this is an example of spanning tree. So consider we are having a 4 nodes A, B, C, D. So it consists the edges from A to B, the weight would be 5. Then A to C 6, C to D 3, B to D is 2. So consider, we are going to find the minimum cost among all the edges. So if we are calculating all the edges A to B, A to C and C to D, the total sum weight is 14. So consider we can make another minimum spanning tree A to C, then C to D, B to D. It consists 11. So likewise we are constructing a spanning tree. From that spanning tree we are going to finalize which one is the minimum sum of the given spanning tree. So here A to B and B to D and D to C it consists the minimum weight. So total weight of the given graph is 10. So here the minimum spanning tree would be taken as this one. So minimum spanning tree that is selected from the above spanning trees of the weighted graph is sum is equal to 10. So here this is another example of calculating the minimum cost spanning tree. So consider this is a graph. From this graph we have to finalize how many nodes totally in that graph. 11 nodes. How many edges we are having? That 13 edges. From that spanning tree we are having 10 edges. So this is a spanning tree. We are going to calculate the minimum cost from the given graph. So this is the red color indicates the minimum cost among all the nodes. So this is the cost of 51. So this is the one way to calculate the minimum cost of the spanning tree? No. So is there any another way is there? So you have to calculate, you have to find the another root from the graph. So this is another way of calculating the minimum cost spanning tree. So total cost is 41. So before that graph we are getting the 51, but in this way if you are framing like the spanning tree we are getting the cost is 41. So what is the algorithm of minimum spanning tree? So it found from a weighted graph by using the algorithms, by using two types of algorithms. One is Prim's algorithm, another one is Kruskal algorithm. So what is Prim's algorithm? It's a greedy technique. It is a greedy algorithm that start with an empty spanning tree. First you can take that empty node, then you can from that empty node we are going to construct the minimum spanning tree from the graph. This algorithm finds the subset of edges that includes every vertex of the graph such that the sum of weights of the edges can be minimized. So next one is Kruskal algorithm. So what is Kruskal algorithm? It is also used to find the minimum spanning tree for the connected weighted graph. Kruskal algorithm also follows greedy approach, which is used to find an optimal solution at every stage instead of focusing on a global optimum. So how does the first we are going to see about the Prim's algorithm. So how does the Prim's algorithm works? Prim's algorithm is a greedy algorithm that starts from one vertex and continue to add the edges with the smallest weight until the goal is reached. The steps of what are the steps to implement the Prim's algorithm? In sense, we have to follow two steps. First one is, first you have to initialize the minimum spanning tree with the randomly chosen vertex. Next, we have to find all the edges that connect the tree in the above step with the new vertices. From the edges found, select the minimum edge and add it to the tree. Repeat the step 2 until the minimum spanning tree is formed. So consider this is an example of Prim's algorithm. Suppose we are taking on weighted graph. So this is a given graph, weighted graph. From this we are having a weight between the nodes B, D 4, BC is 10, CA is 3, then DC is 2, D is 1, CE is 6. So from this, first you have to choose the vertex from the above graph. So from that above graph, this is a graph. From that graph we are taking the root, vertex is B. So second step we have to choose and add the smallest edge from the vertex B. So from this graph we have to find smallest. We are having two paths, one is B to C, another one is B to D. From that we have to consider which one is the smallest one. So here B to D is the smallest one. So you have taken that edge. B to D weight is 4. Among these edges BD is the minimum weight, so add it into the minimum spanning tree. Step 3. So again you have to choose the edge minimum weight among all the edges. So likewise we are having DE and CD such edges. So add them to minimum spanning tree to explore the adjacents of C, that is E and A. So select the edges DE and add it into the minimum spanning tree. So after adding DE we are getting the graph like this. So next step 4, select the edge CD and add it into the minimum spanning tree. Then step 5, again you have to consider the edge CA. Then we cannot able to select CE because it would create a cycle to the graph. So you have to choose the edge CA and add it into the MST. So the graph produced in step 5 is the minimum spanning tree of the given graph. The total cost of the minimum spanning tree is you have to add all the cost among this minimum spanning tree. So that is 4 plus 2 plus 3 plus 2. We are getting 10 units of spanning tree. So this is an what we have done, that how calculating the minimum spanning tree by this way. So next, this is another example. So we are taking the graph of this Prim's algorithm. So from that graph we have to find the minimum. We have to find the minimum spanning tree. So first you can take start node as 1, then add a fringe node as. Then we are having 2 paths, 2 and 4. Then growing up a cheapest in the fringe. Then 4 would be taken. Then it visit 2. No, then can go with 6. Then again likewise we are finding the minimum cost, which one is the minimum among all the edges. From that all the edges we are going to take minimum cost among the 2 vertices. So this is the final cost. So next one is Kruskal algorithm. So Kruskal algorithm. So already we know what is Kruskal algorithm. So it is a spanning tree. We are going to find the minimum spanning tree for the connected weighted graph. So this is also greedy approach that is used to find a optimal solution, that every stage instead of focusing on a global optimum. So how does the Kruskal algorithm works? So we start from edges with lowest weight and keep adding the edges until the goal is reached. The steps to implement, what are the steps to follow to implement a Kruskal algorithm sense? Here also we are having 3 steps. One is sort all the edges from low weight to high. Now take the edge with the lowest weight and add it into the spanning tree. If the wedge to be added creates a cycle, then you have to reject the edge. Until we are going to continue to add the edges until we reach all the vertices and a minimum spanning tree is created. This is an example of Kruskal algorithm. Suppose we are taking a weighted graph. So for this weighted graph we are having 5 nodes, 5 weight of the edges of the above graph is given below. So where edge from A to B the weight is 1, A to C the weight is 7, A to D is 10, A to E is 5, among B is C 3, C to D is 4, D to E is 2. Then AB, another way of the weighting is AB is 1, DE is 2. So we are sorting from lowest weight to highest weight. So after finding that lowest weight to highest weight, we are going to frame a minimum spanning tree. First we are adding the edge A to B with weight 1 to the minimum spanning tree. Next we are adding the edge DE with weight 2 to the minimum spanning tree, and it is not creating the cycle. So now pick the edge CD, the weight 4 to the minimum spanning tree, as it is not forming a cycle. Every step you should check whether this minimum spanning tree is form a cycle or not. After that pick the edge AE with weight 5, including this edge will create the cycle, so discard it. Pick the edge AC with weight 7, including this edge will create the cycle, so discard it. So step 7, pick the edge AD, so weight 10. Here also the cycle is created, so you have to discard it. So final minimum spanning tree obtained from the weighted graph by using Kruskal algorithm is A to B, B to C, C to D, D to E. So totally we are having the cost is 10. The number of edges in the above tree equals the number of vertices minus 1. So algorithm stops here. So we have discussed in this spanning tree, minimum spanning tree, what we have discussed, we are having two types. One is Prim's algorithm and Kruskal algorithm. So both are, we are calculating the minimum cost among the edges. So from that, here we have to, there is no cyclic formations. This is a greedy approach. Thank you.